Alrighty, due to some constraints or whatever for school on Tuesday, we're not going to be able to get the whole lesson in class for especially the second period, and we'll see how fourth period goes. But I want to talk a little bit about some ideas around derivatives and what we talked about the other day. So the first thing I'm going to do is, I'm going to take a look at a graph like this. Let's call this f of x, and I want to look at what its derivative would look like. So I look at the maximum point and the minimum point, and notice up here, the slope of that thing, if I could draw a tangent line, would be 0. And it would also be the slope of the tangent line to f of x here would also be 0. Since the derivative is the slope, then that means that the derivative would contain that point because it's directly below this, and then it would contain this point because that's directly above this, and those are the two spots where the graph is flat. This one could be a little bit better, it could be a little bit over to the right, but you should get the gist of what I'm saying. From here, just notice that f of x is going up in this direction as I move over to the right. It goes down until the min, and then it starts going back up. So I need to indicate the up and the down and the up with my derivative. So when f of x is going up, when the slope is positive, you can imagine drawing tangent lines like this till I get to that spot where it would be flat. Where f of x is positive, where f of x is going up, the derivative is positive, so it's going to follow a little bit of a curve like that. Notice f prime would be higher here than here because at this point f is steeper. When I get down to here, the derivative is closer to 0, so this red line, which represents the derivative, is closer to 0. Similarly, I'm going to be going down on f of x here, so the derivative is negative. You can imagine the slope of these little lines that I'm drawing. They're all going to be negative. It's going to be it's going to be 0, close to 0, biggest. It's probably biggest somewhere in around here. And then the derivative starts to go back up. What I mean is it's still going to be negative, but it's not going to be quite as far from 0 until I get to this point right here where the derivative becomes 0 again. So you can see that it's going to go like this, hopefully. And then over, so you can probably see what's happening here. I've got a cubic looking function, and my red derivative appears to be something that's curved sort of like a parabola or something like that. So from here, my slope is going up. Sorry, I shouldn't say it that way. My slope is positive because f is going up, so it goes like this. Hopefully you understand that and you should be able to draw that for different types of graphs. So I want to look at the function square root of x. We probably talked about this in one of the previous classes. If I have if that's equal to f of x, then I indicate the derivative of that function by calling it f prime of x. If this is equal to y, so if I have y equal to root x, I could refer to the derivative as y prime. It's a little ambiguous. I don't really know what the derivative is with respect to. That may be kind of funky language, but we'll get there. Here I can tell that I'm taking the derivative of f and x is the input. Here I've got the derivative y, and I don't know if my independent variable is x or t or whatever. So I also have dy dx. Remember, derivative is just slope, right? So back to algebra 1, the dy is kind of like a delta y. The dx is kind of like a delta x, which is my rise over my run from slope. So you should see here that I have the graph of f prime of x, or sorry, I have the graph of the square root of x, at least a decent little sketch of it. And I want to know what is f prime of 4. if I'm right, we've actually already calculated this maybe in class. Maybe you haven't realized it yet, or we've kind of talked about this a little bit. So anyway, notice I've got 1, 2, 3, 4. The square root of 4 is 2, so if I follow this over, then that height there should be 2. So that's 2, which makes this 1, right? Actually, we'll just leave the ticks there and not write the 2 and the 1. So it's not quite to scale, but it's good enough. So that makes this, undo. That makes this point, red point, it is 4, 2. So, I'm going to go ahead and do a couple things here. I'm going to draw a blue line, blue dotted line, that is tangent, or kind of close to tangent. It should represent my tangent line at 4, 2. If I can find the slope of this line, then I know the value of f prime at x equal to 4. Because that's how I define f prime. It's the slope of this thing. It's an instantaneous slope. So if I can find the slope of this thing, then I have the value of the derivative there. So what I do is I take a look at this green line that just showed up. So you can see that the green line has a slope that's kind of similar to the blue line. I would say that the slope of this green line is a little bit bigger than this slope. What I'm going to do is take this point and move it closer to that red point. So imagine taking the green line and sliding it, so like that. Notice the green slope is a little bit closer to the blue slope. What I'm going to do is I'm going to go ahead and draw a triangle. What color should I do? Go with yellow. Nope, you won't be able to see yellow. Brown. So I'm going to draw this guy. I'm going to call this delta y and this delta x. So what I have is I'm going to drop a line down to here and call this h. Notice this is, is at a height of 4. Let me point this out. So I've got my 4 and I've got h. What that makes delta x equal to is 4 minus h. That should make sense. If h was 2, which is close to there, in this particular picture, then I would subtract the 2 and get this distance is also equal to 2. Now, I have over here, this height is the height of my function, square root of x, at the x value of h. So what that is f of h. Or I could think of it as of the square root of h. Over here, I've got f of 4, which I know is 2. That's this height right here. Hopefully all 4 of those make sense. What I can do for the y, the delta y, that is going to be f of 4 minus f of h. So what I want you to notice is that as this green line, remember, I want to calculate the slope of this thing at that point right there. So what I'm going to do is take this green line and get it closer and closer and closer to this blue line. So I'm going to take the green dot and slide it in to this dot. So what I want to look at, I'm going to go ahead and write it and it'll show up. Actually, I'm just going to write it out all at the same time. So I'm looking for the limit. Now, I want h. I want to slide this thing in. So how do I slide this thing in? Well, I take h and I move it that way. And that's going to take the dot and move it this way along that curve. So the h is going to slide into the 4. So what I'm actually looking at is the limit as h approaches 4. And then, what am I looking at the limit of? Well, I want to look at this slope. This slope, or the ratio of the delta y over the delta x, so the rise over the run. So I already have that all written out. So I'm going to take f of 4 minus f of h. That's my delta y. Actually, maybe I'll write this out. Of delta y over delta x. Now I just need to sub in my values for delta y and delta x. So this is going to go in for my delta y. This is going to go in for my delta x. So you should see here, as I plug that in, right, now I can calculate that derivative. I can use some of the ideas that we've talked about thus far and figure out what that value is. So I'm going to go ahead and work this out. So what I have is the limit as h approaches 4. Well, what is f of 4? I know that f of 4 is, this is square root x, so the square root of the 4 gives me 2. And then next question is, what is f of h? Well, h is changing, so it's not going to be a number because h is sliding closer to 4. So I just have to write the square root of h like that. That should make sense. And then the 4 and the h stay exactly the same. So I have 4 minus h. Now, this might look sort of familiar. This is a rationalization problem. I need to, if I wanted to evaluate this limit using the methods we've talked about before, I multiply by 2 plus root h on the top and the bottom, and then I would be able to cancel my 4 minus h's. Another form of this thing that would also work is that right there. Now you may be like, well, you just kind of switch things around. Well, sort of, all I did was pull a negative out of the top of the fraction and the bottom of the fraction and cancel them out. So that's another form, and that looks just like some of the ones, oh gosh, what did I just do? Just like some of the ones that we have used so far in calculus when we did all our study of limits. I'm going to show you what a couple others would look like. So I included the original top one. Remember, this was f of x equals root x, and I was looking for the derivative at 4, so I'd write that f prime of 4. So notice all of these have the h minus 4s in the bottom, which means that yes, I'm looking for f prime of 4 here. I'm looking for f prime of 4 here. What's different is the function. See if you can go ahead and guess these two functions. Hit pause. Alright, let's see if you got it right. Here, f of x is equal to 1 over x. And then here, f of x is equal to x. Oh, whoops. This, let's see, I'll keep consistent. Erase. Hopefully you see my error. Those should be h's. Here, f of x is equal to x cubed. Alright, so that's it for this video. Hopefully I got to this point in class, and for the next video you're going to look at the derivatives of functions at any given point. So here we're talking about a specific point, x equal to 4. Now I want to know, well, I don't really care about f prime of 4 if I have, or f prime of 8, or f prime of 20, or f prime of... I want to get to if I have... So what I just found is like, alright, this height is going to be whatever, and it corresponds with this derivative, or with this point. What I want to know is what's the equation of this thing given this equation. So the next video is about how do I start with this equation and get to that thing's equation